Imagine you're given a binary array and a spacing requirement. Your task is to verify that every one in the array is properly isolated. Can you do it without checking every possible pair? Let's break it down. We have an integer array called nums containing only zeros and ones, and a non-negative integer k. Our goal is to return true if all the ones in the array are separated by at least k zeros. If any two ones are closer together than that, we return false. The core challenge is efficiently checking the gap between every adjacent pair of ones. A naive approach scans the array from left to right. Every time we find a 1, we start another loop scanning forward to find the next one. We then calculate the distance between them. If the number of zeros between them is less than k, we return false. This works, but does a lot of redundant scanning. We end up retraversing parts of the array we've already seen, leading to O of n squared time complexity in the worst case, though it uses no extra space. The key insight is that we don't need a nested loop to find the next one. We only ever care about the distance between a 1 and the last one we encountered. We can solve this in a single pass by simply remembering the index of the most recently seen one. We initialize a variable, last, to -1 to indicate we haven't seen a 1 yet. As we iterate through the array, when we hit a 1, we first check if last is not the initial -1. If we have a previous one, we compute the gap as the current index minus the last index minus 1. This gives us the number of zeros between them. If this gap is less than k, we immediately return false. Otherwise, or if it was the first one, we update last to the current index and keep moving. By the end of the loop, if we never found a violation, we return true. This single-pass approach is the optimal solution. Let's trace this on the example where nums is 1, 0, 0, 0, 1, 0, 0, 1, and k is 2. We start with last set to -1. At index 0, we see a 1. Since last is -1, we skip the check and update last to 0. At index 1, it's a 0, so we do nothing. Same for indices 2 and 3. At index 4, we find another 1. Now last is 0, so we calculate the gap. For -0 minus 1 equals 3. 3 is not less than 2, so it's valid. We update last to 4. Index 5 is a 0, index 6 is a 0. At index 7, we find the final 1. Last is 4, so the gap is 7 minus 4 minus 1, which equals 2. This is not less than k, so it passes. The loop finishes, and we return true. For this input, the final result is true. Every pair of ones has at least 2 zeros between them, satisfying the distance requirement exactly. You'll spot this pattern whenever a problem asks you to validate a condition between adjacent elements of a specific type in an array. The concrete signals are needing to check distances between occurrences and finding that a full pairwise comparison is unnecessary because only consecutive occurrences matter. Time complexity is O of n as we iterate through the array exactly once. Space complexity is O of 1 since we only use a single integer variable for tracking. Try the next problem on checking maximum consecutive ones. It uses a very similar single-pass tracking pattern. Subscribe for more.